So there are two more topics to cover in lecture 4. These are not related to energy generation. They're related to other behaviors. But the first one will be biofilms, and they're a structure that bacteria make. And the second is quorum sensing, which is a thing they do. So let's look first at biofilms. It turns out that most bacteria live in biofilms. So in the ocean, there are bacteria freely swimming around in the water, and in lakes, there are bacteria freely swimming around in water. But if you look, coating every little grain of sand in soil all over the world, they're coated with biofilms. Every rock in a stream that has a slimy surface, well, that slime is actually the biofilm. So if you pick up a rock in a river and it feels kind of like smooth and slippery, that's because it has a really thin layer of biofilm on it with bacteria. And so what they do that for, like, why do they make those biofilms? Well, a big one is just attaching to surfaces. So if we think about the biofilm on the rock in the river, the idea is those cells can stay there on that rock, and if they're in a river, they're not getting a lot of nutrition. There isn't like a high concentration of carbon molecules and nitrogen molecules and other stuff. Those things are in low concentrations in a river. But if cells can like hang out on a rock, whatever molecules they are will flow to them, and whatever waste products they generate will flow away from them. So it's kind of a nice way for them to get access to low concentrations of things they need. And that's really important because they grow slowly. If the concentrations of what they need are low, they can't grow very quickly. So they have to be attached to a surface to grow at all. And it is what it is. And also, biofilms give them protection from being eaten, predation, and also allow them to work together. So they allow them to do collective actions in some cases. So this is really how you should think about biofilm formation. It goes in several steps, and they're constantly changing. So we start with some cells that decide to attach, and they attach. And they start to divide a little bit. And other cells, well, their daughter cells, once they detect that there are enough of them there, they start furiously making the polysaccharide matrix. And a lot of the cells are making this matrix, and they build this structure that's kind of, I don't know, it ends up being sort of like a mushroom, but much smaller. This is still microscopic. This is like 50 micrometers tall. So that is 0.05 millimeters. So you can't see that. Yeah, and so eventually these cells will be in a polysaccharide layer so thick that it's limiting the diffusion of food to them and of waste away from them. So then they'll switch back to non-biofilm behaviors. So they will grow, like, that's why they show flagella on these, is that they've decided it's time to leave the biofilm. So once it gets too crowded, a lot of cells will leave. And they are able to maintain some kind of balance. And this is what we would see under a fluorescent microscope looking at biofilms, where it's just this net with a lot of empty spaces in it. And those empty spaces allow water to flow through. And that, again, serves that function of bringing nutrients to the cells and removing waste products from the cells. And the idea is any cell shouldn't be more than like 10 micrometers away from the water, even though they're in this huge structure. So one of the most close to home versions of biofilms would be dental biofilms. And this is a famous picture where a person has used a dye that stains biofilm after toothbrushing to find out how effective the toothbrushing was at removing the dental biofilms. And then this would be what a scanning electron microscopy picture of a biofilm might look like. It's just a jumble of three-dimensional polysaccharide structures with little tiny cells throughout it. In healthcare, we have to think about biofilms all the time, because if pathogens are growing in a person in the form of a biofilm, they're protected against phagocytosis. They're protected against the antibodies our immune systems make. They're protected against the antibiotics that we might inject or eat. And so they're very difficult to remove in a lot of cases. So some examples where you see them in a clinic would be, this is probably the worst common example, is bacterial endocarditis or heart valve infections. Some of these would actually require surgical removal and replacement of a heart valve, because there's nothing the bloodstream has that can protect it against certain biofilms. But a more common source of biofilms would be indwelling devices like catheters. One thing we take for granted in health is that all of our external surfaces are epithelial layers that have some form of shedding. They're being replaced by stem cells that make new epithelial cells all the time. So especially on our skin, we're constantly losing the top layer of our skin. And that's beautiful, because whatever bacteria or viruses or fungi have landed on our skin, they go away when the skin cells fall off. And that protects us from a lot of bacterial infections. But a catheter, which is made of plastic, for example, doesn't have that protection. And so anytime you have a line going through the skin into a person, a biofilm can develop on that plastic and be introduced into the person. So that can be a source of nasty infections. Okay, so that is biofilms. And it's a pretty short video and a short number of slides for what really is an essential thing to know about microbiology. Biofilms are where you find bacteria in nature, and they're common even in a human. So do with that information what you will, and I'll see you in the next videos.